In this video, I will show how to find the limit of a function using the graph. So in this problem, the graph is given, and we just have to describe the behavior of the graph using the language of limits. So the first limit is as x goes to negative infinity, and when working with limits, you basically have to understand that what is it asking you for. So we're looking at the output of the function as x goes to negative infinity, and from this graph it appears that the function has a horizontal asymptote at -1. So using the language of limits, we say the limit of f of x as x goes to negative infinity is equal to -1. The next limit is as x approaches to -3 from the left, and again we're looking at the output of the function. The output is the y-coordinate, so as x approaches to -3 from the left, what happens to the output? The output goes to 2. So we describe that or such behavior using the language of limits as limit of the function as x approaches to -3 from the left is 2. Now, same question, but now the limit approaches to -3 from the right. But as you can tell, the output of the function as x approaches to -3 from the right is also approaching to 2. So we say the limit of the function as x approaches to -3 from the right is 2. When the two one-sided limits both exist and equal to one another, we say that two-sided limit as x approaches to the target value exists and is equal to that same value. So in this case, the limit of f of x as x approaches to -3 is 2. However, f of -3 does not exist. So here you have to remember that limits are not about the values of the function at the point, but the behavior of the function as x approaches to some point. Next, we continue to the next value, 0. So the next limit is as x approaches to 0 from the left. And again, we're looking at the output of the function or the y value. So as x gets closer and closer to 0, the output also gets closer and closer to 0. So we say the limit of the function as x approaches to 0 from the left is 0. However, on the right side, we have a different story. Here, as x gets closer and closer to 0, the function gets closer and closer to 3. So we say the limit is equal to 3. What is the limit of the function as x approaches to 0 regardless of the side? Well, this limit does not exist because the two one-sided limits do not match. What is the value of the function at 0? Well, according to the graph, the value of the function at 0 is 3. So again, the value of the function has nothing to do with the limit of the function as x approaches to 3. We have seen an example where the value of the function does not exist, but the limit exists. This is an example where the function exists, but the limit doesn't exist. Next, we move on to x equals 2. So what's the limit as x approaches to 2 from the left? Well, the function approaches to 1. Same story on the right. As x approaches to 2 from the right, the output of the function approaches to 1. Again, since both one-sided limits exist and equal to one another, we say the two-sided limit also exists and is equal to the value of one-sided limit. So in this case, it is 1. However, f of 2 is -1. So this is another example where the limit of the function is not necessarily equal to the output of the function at that point. Next, what is the two-sided limit of f of x as x approaches to 5? Again, it looks like both one-sided limits exist, and it looks like they all go to 3. As x gets closer and closer to 5, the output gets closer and closer to 3, and the same behavior is on the left and the right, so we say the limit of this function as x approaches to 5 is 3. Now, as we get closer to 6 from the left, it looks like the function goes down to negative infinity on the left and the right. So using the language of limits, we write it this way. The limit of f of x is equal to negative infinity on both sides. So we may say that the two-sided limit as x approaches to 6 is also equal to negative infinity, as both one-sided limits are the same. Now, as x approaches to infinity, what happens to the output? Well, as x gets larger and larger, the output gets also larger and larger. So in this case, we say the limit of f of x as x approaches to infinity is equal to infinity.